Hi, and welcome to Chem 111. We're going to, I'm going to narrate these PowerPoints so that you can follow along with me, hopefully. All right, so first of all, let's start out. What is chemistry? Well, chemistry is the study of the composition, structure, and properties of matter, energy, and changes that matter undergoes. Okay, so what does that mean? Well, first of all, what is matter? Matter is anything that occupies space and has mass. So basically, that means chemistry is really the study of everything we see, what we don't see, what we touch, what we feel. So that's probably why you're taking chemistry. Chemistry is often called the central science because it's related to pretty much every other science that's out there. Okay, so what are we going to learn about this semester? And if you continue on for second semester chemistry, we'll learn about the building blocks of matter. So I'm sure you've heard of atoms, molecules, ions, nucleus, protons, neutrons, etc. We'll find out how they were discovered, how they relate to each other, how they're different, how atoms, molecules, and ions combine with each other. We're going to look at types of reactions, heats of reactions, properties of compounds, the shapes of the molecules, stoichiometry, which is the amount of products, how much can you produce, etc. All right, so like I said, chemistry is the central science, but there are different types of chemistry. Organic chemistry is the study of carbon-based molecules, all your methane, ethane, propane, benzene. That'll be sort of a whole nother course in itself that if you need to go on and take more chemistry, you'll have a whole year of organic. Biochemistry then takes organic chemistry and talks more about the chemistry of life. Inorganic chemistry is pretty much everything else, all the molecules and atoms besides carbon. Physical chemistry describes the properties of the atoms, properties of molecules, how they bond, what their shapes are, how fast they react, reaction rates, etc. And then analytical chemistry is the measurement of quantification of something if you need to know how much there is, or identification if you need to know what you have. That's analytical chemistry. All right, so let's start with the scientific method. Pretty much experiment and explanation are the heart of chemical research. So what happens? We start with a hypothesis, which maybe you notice something and you think, whoa, I wonder why that happens. So you sort of get your idea in your head. Well, I think it happens because of A. So it's a tentative explanation or a prediction of something that you've noticed. Then experiments are run. Observations of natural phenomenon, or everything is in a controlled manner. It needs to be able to be duplicated not just by the scientists, but by other scientists as well. And so generally, if a positive result comes about, then it supports the hypothesis. If a negative result happens, then it invalidates the hypothesis. If both are important, negative results mean generally that you need to revise your hypothesis to see, where these new results might lead. And so after a series of experiments, you start to see relationships or regularity in results. All right, so if the hypothesis is consistently held up, now we create a general rule or conclusion. Or of conclusion. So the hypothesis then becomes more of a theory. So a theory is defined as a tested explanation. However, it's never proven. That's what I was starting to say on the next slide. We never actually don't ever say that proves that. Usually if something works the way we expect it to, we say, well, that supports our theory or that supports our hypothesis. So further experiments may need to show that theory needs to be revised. Either some new instance comes along that changes the results that we get, or new instrumentation comes along that can measure things more carefully than what we had before. And so theories can be revised. And in fact, an example of that is the structure of the atom. So, hundreds of years ago, they had an idea of what the atom looked like. And they thought that there was this smallest thing called the atom, and then different scientists came along and said, well, no, actually there's something inside the atom, and those are the protons, neutrons, electrons. And so different experiments came along to revise the theory, but it's not usual that you have to change it outright, but often they have to be revised. All right, so actually some relationships are so fundamental that we can call it a law. And so a law is a concise verbal statement or mathematical equation that tells us something. For example, matter is neither created nor destroyed. That would be the law of conservation of matter. So it's just a concise verbal statement. Or E equals mc squared. That would be a mathematical equation, which is a law about energy and mass and etc. Okay, there you go. The example: mass is neither created nor destroyed. All right, so the scientific method, sort of as I was starting to describe, works like this. So you have an experiment, you get your results, you either you kind of have a hypothesis to start with, but you make a hypothesis from your results. You do further experiments. Sometimes you get positive results that support the hypothesis. Sometimes you get negative results that lead to modification of the hypothesis. You have to do further experiments to try to go even further. You keep going. Eventually, a theory follows. And then still further experiments will try to expand the theory, try to apply the theory to other situations, etc. I'm not going to read this slide. You can come back and look at it, but it's a particular example of the scientific method. Okay, so since chemistry is the study of matter and all its properties, we're going to break matter down a little bit more and look at it a little more carefully. So, there are two principal ways of classifying matter. We can classify it by its physical state. Is it a solid? Is it a liquid? Is it a gas? We can also characterize it by its chemical constitution. So is it an element, is it a compound, or is it a mixture? All right, so you probably know this back from elementary school, middle school. But anyway, let's review. What is a solid? The solid is the form of matter characterized by rigidity. So a solid is pretty incompressible. You can't smush it any further together. It has a fixed shape. It has a fixed volume. Molecules are packed close together. A liquid is a little bit looser than a solid. It's still pretty incompressible. It's hard to push liquid closer together than it already is. However, although it has a fixed volume, it doesn't expand to fill a container. It does not have a fixed shape, and so it will take the shape of whatever container is holding it. And then finally, a gas is the form of matter that molecules are spread out. That makes it very compressible. You can push molecules closer together. We know that a gas has no fixed volume or fixed shape, so it will fit into a container of any size and shape. Okay, we just have some pictures. So solid, rigidly packed molecules. Liquid, they're a little bit more random, still packed close together. And then we have our gas, which molecules are very far apart. So let's talk about some other properties of matter. We can also classify matter by its physical property or its chemical property. So a physical property is a property or characteristic that can be observed for material without changing its chemical identity. What are some physical properties that we can think of? Well, first of all, what we just talked about, solid, liquid, or gas. What is the state of that matter? That is a physical property. It's color. Oh, melting point. Color. So a chemical property then is a characteristic of a material that involves chemical change. So how does oxygen react with gasoline? So for example, gasoline is flammable in oxygen, but water is not flammable. Iron reacts with oxygen in a slow process to produce rust. So a chemical property is something, so we know it's changing to something else. How does it do that? And be careful, because sometimes we could say, oh, well, that metal is inert. You might say, well, it's not reacting, but that would still be considered a chemical property because it describes how it reacts. It doesn't react very well, in other words. So let's do a few examples. Determine if the following are physical or chemical properties. Chromium is a steel gray solid. That's physical, it's just description. Hydrogen reacts readily with oxygen. Since you see the word react generally means chemical. Nitrogen freezes at negative 210 degrees Celsius. Again, that's just describing it's the freezing point of nitrogen. It just identifies nitrogen. It's physical. Milk will sour when left in a warm room. Souring is a type of reaction. Something's happening within the milk, and so that would be chemical. Mercury is a liquid at room temperature. Again, that's just really more descriptive of mercury. It's physical. Aluminum foil has a shiny appearance. Again, that's physical. Gasoline is flammable. That would be a chemical. It turns into a flame. It reacts. That's chemical. This one's a little tricky. A platinum pin will not tarnish in the air. You might at first think physical because it's not doing anything, but it is describing a way that it reacts or doesn't react. Platinum does not react in air, and so we're describing something chemical about platinum. All right, we can further look at, in a very similar way, we can look at physical changes versus chemical changes. So in the same idea that we have physical properties and chemical properties, we can have physical and chemical changes. So what is a physical change? A physical change is something that is a change in the matter but not its chemical identity. So the most obvious things there are melting point, boiling point, a change in state. So a physical change is usually reversible. You can melt ice, you can refreeze it, although not always, because another physical change, let's say you had a piece of paper and you tore it into small pieces, that's also a physical change. Or if you pulverize a rock, that's a physical change. So those are not reversible, but often physical changes are. But the key thing is that no new compounds are formed during a physical change. So it's either a melting, a boiling, a freezing, etc. There you go. So then a chemical change, which is the same as a chemical reaction, would be when the property when something changes to something else. So a change in which one or more kinds of matter is transformed into a new kind of matter or several new kinds of matter. So chemical changes are usually irreversible. New compounds are always formed, so there's usually some kind of change, a color change. You can often see steam being produced or bubbles, which means a gas is being produced. The rusting of iron is an example of a chemical change. So you see, when you see iron rusting, you see a color change, a new compound is being formed. Okay, a few examples of this one. Determine if the following are a physical or chemical change. Frost forms on the lawn. Well, that's just a physical change because it's just forming ice. It's going from liquid to solid. Wood is chopped in the fireplace. Again, that's just physical because you're just making wood smaller. Carrots are grated for use in a salad. Again, just physical. We're just changing the shape of the carrot. Malt undergoes fermentation to make beer. Okay, we're changing one thing to another. Fermentation is kind of a reaction word, and so that is a chemical change. A copper wire reacts with air and turns green. Well, right there you see the word react again. That's chemical. Bleach removes a stain. That's chemical. Something's happening. There's a reaction going on. Okay, this one's a tricky one. Sugar dissolves into water. Well, all that's happening when you dissolve sugar in water is that they're mixing. They're mixing really well, and you can't see the dividing point between them, but it is still just a physical property because you're just mixing the two. You're not changing sugar into water. You're not changing water into sugar. You're not changing anything else into anything else. You're just mixing the two, so that's a physical property. Gold is hammered into thin sheets. Again, that's physical. All right, so another way that we can characterize compounds is by whether it's an element, a compound, or a mixture. So millions of substances are characterized, and all of these substances make up matter. And let's look at this next chart. We can classify them. So all matter, we can have substances or we can have mixtures. So pure substances or mixtures. A mixture, let's look at substances first. And notice that to get from a substance to a mixture, you have a physical process. So, if you have salt and water and then you mix them together to get a salt-water mixture, that's a physical process. We can further divide substances into elements and compounds. So an element would be something, and we'll talk about that in just a second, something from the periodic table. A compound is made up of two or more elements. To go from an element to a compound, you have to go through some kind of chemical reaction. Going back to the mixtures, we can have mixtures that are homogeneous or heterogeneous. Homogeneous just means that they look the same all the way through, and heterogeneous means that you can pick out different parts. All right, so this is pretty much what I was just saying. So a pure substance is any kind of matter that cannot be separated into other kinds of matter by physical means. That's just a different definition. You can't take water and separate it into hydrogen and oxygen without changing it. That would be a chemical process. So water is considered a pure substance. A mixture is something that can be separated by physical means into two or more substances. If you take your salt water mixture, you can evaporate the water off and you still have your salt. So you can evaporate the water and capture it. You can keep the salt. Those are two different things. Okay, so then a compound is still a pure substance, a substance composed of two or more elements chemically combined. So the smallest unit of a compound is a molecule. Examples: H2O, CO2, CH4. CO2, carbon dioxide, H2O, water, CH4, methane. Compounds follow the law of definite proportions, which means that no matter where they come from, they have the same proportions so wherever you get carbon dioxide from, it always has one carbon and two oxygens. This ratio never changes if it's carbon dioxide. Of course, it can change in other compounds, but then it's no longer carbon dioxide. And remember that the elements in a compound can only be separated from each other by a chemical process, not a physical process. So if you can separate two things by a physical process, then that is not a compound or a pure substance. That would be a mixture. So again, we can pull the C's and the O's from carbon dioxide away from each other, but then we don't have CO2 anymore. We have carbon and oxygen. And just by the way, there are a few elements that exist as multiple in the molecular form. So for example, O2 is elemental oxygen. It's a molecule of oxygen with two oxygens stuck together, but it's still, you would consider O2 an element because it only has oxygen. Same thing with nitrogen, N2. There's actually 7 elements. They're mostly at the right hand of the periodic table: bromine, iodine, chlorine, fluorine, oxygen, nitrogen, and hydrogen all form diatomic molecules, which means there's 2 atoms, but they're still considered elements because they are just one type of atom. All right, so now we have mixtures. And again, mixtures are classified as heterogeneous if they are physically distinct. So if I pour a bucket of salt and a bucket of pepper together, salt and pepper, mix them together, that would be heterogeneous because you can see the differences. A homogeneous mixture then is when the properties are uniform throughout. So if you dissolve salt in water and mix it up, it will be homogeneous because it's everywhere. No matter where you took a sample from in that solution, it would be the same properties, the same ratio, the same concentration, etc. So, and unlike a pure compound, mixtures can have variable composition. So a pure compound always has 1 C to 2 O's or 2 H's to 1 O, pure water. But mixtures can have variable compositions and variable properties. So like if you put a teaspoon of sugar in a cup of water, or if you put a full cup of sugar in a cup of water, they're going to have very different properties. One will be thicker, one will be thinner. One will be sweeter, one will probably be darker color, etc. So mixtures can have variable compositions. Well, there you go. You can add sugar to water in any amounts, and it's still a mixture, and usually homogeneous unless you add so much sugar that you can't dissolve anymore. Each different mixture will have different sweetness, will have different texture, different thickness kind of thing.